Hello, welcome to Marsh Mathematics, and in this video I'll be looking at differentiation from first principles for year 1 and for year 2. Now before we do an example, I'm going to go through where the formula comes from. This formula that I'm going to prove is given to you in the formula booklet that's on the paper, but I just want to show you how it's derived. Now I'm going to just go over it and I take this in blue. Okay, so this is just a curve y equals fx, any function of x, and if I wanted to find the gradient of the chord by the way is just a line made joining 2 points on a curve. Okay, so BC is just a chord or a line joining 2 points on a curve. Now if I wanted to find the gradient of that line, if you look over here, you know how to find the gradient of a line using a straight line using that formula. Okay, now if I form a triangle ABC, right, we have to consider 2 points B and C. Okay, now the x value is h. The difference between the two x values, this is x and this is x plus h, so the difference between them is h, between B and C, and the difference in height, or the y values, is fx plus h minus fx. So this really is just y2, this is y1, this is x1, and this is x2. Okay, and so all this here, this tan theta, this formula here, is just really the same as this formula here, which you know for a straight line. Now that's the first thing that confuses people, but you just have to think about, because really what we're saying is that y2 is equal to fx plus h, and y1 is equal to fx, okay, and h is equal to x2 minus x1. That's all that means. Okay, now this is the big theory for differentiation. You see, this is the big leap forward. We say that we have to imagine that this is a chord now. BC is a chord, but if C moves nearer and nearer to B, that means that H is going to become naught. Okay, it's going to move down the curve towards B, and so that means H, it'll just become the one point, it'll just become the point B, and BC won't be a chord anymore, it'll be a tangent, okay, to B. It will be a tangent to B, so it will be the gradient of the tangent at B. That's what we're after, you see. And so as H tends to naught, C moves towards B, okay, and the chord becomes the tangent to B. So the gradient of the tangent is this. We've just proved that before, but we have to put in for the limit as H tends to naught. It's very important that you include that. Okay, so the tangent of the chord is this, but the tangent, the gradient of the tangent at B is exactly the same formula, but as H tends to 0. Okay, so it's a limit. So that's, you are given this formula, but you must try to understand where it comes from. Okay, now I'm going to do an example, because I don't think they'd get you to prove it, but as long as you sort of understand where it comes from. Okay, now the reason that they like giving you questions on this is because it helps you to, it brings forward a couple of ideas from the first year about the binomial expansion as well. Okay, and so if we look at this example here, this one, first thing we have to write down is the formula. That's how it's given you. So it's f dashed x. That f dashed x just means exactly the same as dy by dx. Okay, because remember, okay, they mean the same thing. Okay, now if we let, they haven't said this is fx, but we can let fx y equal that fx. Okay, so we can substitute it into the formula, and all we do, we substitute fx this into the formula, into this formula. So f of x plus h is just going to be this, x plus h cubed minus 2x, okay, x plus h in brackets minus fx, which is just this. Now, one of the things that people get to this stage and then start messing it up, but what we've got to remember is that this part here, this expansion here, is just a binomial, so you can just use Pascal's triangle and the binomial expansion. Okay, so what I do is I do it separately first, make sure I've got it right, then I'll put this bit in, because the other bits, this bit and this bit, are okay. And so you end up with a great, I know it looks really complicated, but it's just substituting everything in. Now what happens now is a lot of things, some things cancel. Okay, the x cubes cancel. Okay, that one cancels with that one. The 2, that becomes a plus 2x, the 2x's cancel, and when everything cancels you end up with this. Okay, now the good thing to do now is you must always write this thing, the limit as h tends to 0 as well, is that we factorize the top line and then we can cancel that h's, okay, and we end up with this. So as the limit, as h tends to 0, 3xh is going to be 10 to 0 and h is going to tend to 0. So these two are going to tend to 0. But it's okay just to write this and then just write the next line. So that's what we've got. But you know, okay, by just checking it, if we differentiate that, you know that you just multiply by the power, take 1 off the power, and that's what we get, just a double check that we've got that right. So that's differentiation from first principles. And in the second year you should be able to do this with sine and cos as well, using trig identities. Okay,